Assalamualaikum class. So for this video, I will explain to you how we do the analysis for the cation. Cation, cation means positive charge ion, and basically it is a metal ion lah. Okay, so this how we do the analysis for the cation. Okay, first, you add, let's say in this test tube, you have the cation. Okay, so to prove which cation, you have several cation. Group 1 cation, Group 2 cation, and transition element cation, and also Group 3 cation. As you know, from Group 1 until Group 3, all of them are metal and they have the positive charge. So how you want to test which this solution contain which positive charge, okay? So this analysis you need to conduct by add sodium hydroxide, but the key word here is you add little by little until excess. So you must add a little bit by little until you add more sodium hydroxide. You cannot add directly all sodium hydroxide together. Okay, so that's how you conduct the analysis. Okay, so how you want to memorize? Okay, there is a technique here. Basically you don't need to memorize. Basically you can if you understand, you can try use this technique. Okay, so if this solution contain group 2 cation, for example you have Mg2 plus and Ca2 plus, you can refer to your periodic table. Okay, if you have group 2 cation, what the observation you will see white PPT, means white precipitate form, and insoluble in excess sodium hydroxide. Okay, so what does it mean? Initially, when you put if you have group 2 here, if you put sodium hydroxide a little bit, they form white precipitate. But if you put more sodium hydroxide or excess sodium hydroxide, this white precipitate, they still form the white precipitate. They will not soluble in excess NaO. So means you will see a precipitation that will settle down at the bottom of the test tube with the white color. Okay, group 2 is white color. Okay, so other than group 2, you have another white color also, but they are not group 2. Okay, for example, you will have aluminium, you have Pb2 plus and Zn2 plus. Okay, if you see in your periodic table, these three ion is not in group 2, but they are white color also. So for non-group 2, they will form white precipitate but soluble in excess NaO. Sodium hydroxide, what does it mean? If you put a little bit sodium hydroxide initially, you will see the white precipitate. But if you put excess sodium hydroxide later that, you will see that this precipitate will dissolve in excess sodium hydroxide. So that's how you differentiate the cation, if this solution contain group 2 cation or contain non-group 2 cation, which is white color. Okay, but as you know that transition element, some of them have color. So that's why before you watch this video, you should watch first my video for the part 4 to see the color of the salt. Okay, so you can have the blue color. Remember, blue means you have copper. Only copper contain blue color, Cu2 plus ion. So what you will see if you have copper, so you will see precipitate. Basically transition element, they will form a precipitate, and copper is transition element, so that's why they will form the blue precipitate. Insoluble in excess NaO. Okay, so they form insoluble. Remember, if you have blue, it's referred to copper only, nothing element, only copper is blue, but it is insoluble because they are transition element. Okay, so from now onwards I will use the word IIE, means insoluble in excess, a short form. Okay, let's look at for Fe2 plus. As you know that Fe2 plus is a green color in the past video, so they are transition element. So if you put sodium hydroxide in Fe2 plus, of course the color form will be green precipitate. Okay, they will form the green precipitate. Sorry, here my mistake, should be green precipitate. So but as they are transition element, they also will be insoluble in excess NaO. Okay, insoluble in excess NaO. Okay, for the next cation is Fe3 plus. As you know, Fe have two charge, 2 plus and 3 plus. Fe3 plus, the color is brown. So if you add sodium hydroxide, they will form brown precipitate. And because they are transition element, they form brown precipitate insoluble in excess NaO. That's how you remember. Very easy. If the color is very easy, because you know blue, copper, green Fe2 plus, brown Fe3 plus. But you need to be careful for the white, because white is either non-group 2 or group 2. Okay, so before I conclude, let's go to the final cation, which is chromium. Okay, chromium basically also part of transition element because they have color of green. They almost same with Fe2 plus, the green color. But here they have exceptional. For chromium, they form green precipitate but soluble in excess now sodium hydroxide. So initially, when you put sodium hydroxide in chromium, you will see green precipitate. But if you put excess sodium hydroxide, you will see that this green precipitate is soluble and make it the solution become green color because of chromium. So chromium basically is green. But so here, even though you have two green color, you need to be careful. Remember, Fe insoluble, chromium will form soluble in excess sodium hydroxide. Okay, so about the color, I think you can differentiate because the color is not so much blue, copper, or green Fe2 plus, chromium, but Fe will insoluble, chromium will soluble. Fe3 plus is brown. Very simple, very easy to remember if you you keep reading the notes. Okay, but for white, remember if group 2, they will form in white precipitate insoluble in excess because they are group 2. Non-group 2, for example, the white color is as aluminium, lead, and zinc. They will form the white precipitate soluble in excess now. That's how you differentiate for the white color. Okay, next let's proceed to second test. Second test also you want to test cation, but just now you add sodium hydroxide. But now this one you will use ammonia. Okay, let's look at first for the white color. Okay, for the white color here, first you can remember for period 3. Okay, if you check your period 3, okay, you have magnesium and aluminium. Except for Pb. Pb is not period 3 lah, but they same with the period 3, aluminium and magnesium. This element in period 3 are white color. So if you put ammonia in period 3, which is aluminium or magnesium or Pb, okay, so they will form the white precipitate insoluble in excess ammonia. Okay, so I hope you're not confused with sodium hydroxide just now. This one is period 3. I repeat, period 3, which is aluminium, magnesium, exceptional for Pb. Pb is not period 3, but they will, if you put ammonia, they will form white precipitate insoluble in excess ammonia. Okay, they will form white precipitate insoluble in excess ammonia. Okay, but let's look at Ca. Ca is a group 2. Okay, especially Ca, if you put ammonia in Ca, nothing change, or you can say no precipitate. Okay, you cannot see a reaction. Nothing can be seen. Okay, if you have Ca2 plus. Okay, so next, the another one, the white color is zinc. Okay, zinc. This is exceptional for zinc. Zinc is not a period 3, so zinc will form white precipitate soluble in excess. Okay, very easy to remember. Period 3 form the white precipitate insoluble in excess. Only zinc form the white precipitate soluble in excess for the white color. Okay, for the color is very simple, like blue. Of course, you know already copper, right? Just now, copper is insoluble in excess. But now, what happened in ammonia? For copper, they will form the blue precipitate soluble in excess ammonia solution. Okay, they will now, just now they are insoluble for sodium hydroxide, but now they form the soluble in excess ammonia. Okay, Now let's look at for the green. Okay, if I say green, what comes to your mind is either chromium or Fe, right? Okay, we go to Fe first. Fe2 plus. What will be the color of precipitate? As you know, it will be green because Fe2 plus. And it's same with sodium hydroxide, which is insoluble in excess ammonia. They are insoluble in excess ammonia. Okay. So for brown, what do you think for brown? Fe3 plus, right? Okay, so what is the color of precipitate? Of course, brown precipitate insoluble in excess ammonia. So that's why I said for color is very easy because the analysis will be same. Okay, but for this green of course it refer to chromium. Okay, chromium here. For the if you put ammonia in chromium, as I mentioned here, is green, but you need to be careful. It's not green. For in ammonia, the color will be uh, gray green. Okay. If you see chromium in sodium hydroxide, they are soluble in excess. But in ammonia, okay, in ammonia, they form the gray green insoluble in excess ammonia. Okay, so here actually they are reverse with your copper. Okay, what does it mean I said reverse? Okay, let's look at for copper. Copper, this one they form with sodium hydroxide, they form insoluble in excess, right? But with ammonia, they form soluble in excess. So they change from sodium hydroxide to ammonia. But for chromium, in sodium hydroxide, they form soluble in excess sodium hydroxide. But for ammonia, they will form insoluble in excess ammonia. Okay, so I hope you can copy down inside your module and you can understand how uh, what is the analysis for each cation. I don't encourage you to memorize. Okay, there is a technique how you want to know the color without memorizing. Okay, so my advice, keep doing the exercise that I give to you. Inshallah, you will remember the color for each cation. Okay, so that's all for now for today's video. So we end with this topic already. Uh, so please make sure you complete all the homework that I give to you. Okay, thank you.